This kinetic sculpture uses two rotating discs that overlap, and by varying the speed of the rotation or the design of the discs, you can get some different interesting visuals. Similar sculptures like this have been around for a while, so I thought surely there's gonna be a bunch of 3D printable models that I can just download, print and build, right? So I went looking and I found some with DC motors, some wind powered, some like fidget spinners, and various designs with spring-loaded mechanisms. But I was imagining something I can just put on a wall and turn on. No winding, no noisy mechanisms, something I can just place there, turn on, leave running. But then I found this Instructable by Dushyant Ahuja. It describes a printable design with two DC motors. However, it is also pretty big, and I was imagining something more compact. He even mentions some future plans with a lot of good ideas and recommendations for improvements, but this was about 8 years ago and I don't see any updates. Hi everyone, I'm Rob, and after seeing this Instructable, I knew I had to build my own version and put my own spin on it. I started with a circular base and two motors pointing in the same direction, simply because I wanted the 3D printed gear transmissions to be hidden in the back. And the rotation is then transferred through these two nested shafts onto the interfaces in the front. And it works. The mechanism is hidden on one side, then it's being transferred through these nested shafts onto the front where I have these magnetic interfaces. So I think the first version had the potential to work, but I didn't like that it was using DC motors. I decided that I will have more control using stepper motors just regarding the speed, and I also didn't like it was using two different types of bearings. And I just knew I could make the thing more compact if I use the same bearings and if I just flip the motor around so I don't have them pointing in the same direction. So that's what I did with the second version. One of the motors now faces forwards and one of them faces back as before, and the mechanism is using 4 of the same 608 bearings. And since I decided to use the stepper motors, that meant I had to fit the drivers and microcontroller and so on in there somewhere as well. I left this area here, which should be enough to fit all the components I need. And based on that, I designed a custom PCB. But it was at this moment I knew I messed up. Look at this. Why is this mirrored? This is what happens when you don't double check the layouts you find online. Yeah, well, luckily the second version was okay. I'm using the chassis 6 TMC2209 drivers and I fit a DC buck converter in the back. So normally these cheap stepper motors are unipolar. That means I can't use the fancy drivers to make them go quietly. There is a modification, however, I can use. If you take the cover off and then cut the trace right here in the middle, you basically convert it from unipolar to bipolar. But it's a bit of a hassle and it's hard to put the cover back on. So I made this tool to make the modifications easier. All you need is a 2.5mm drill. First you put it here to measure the distance you need, and then you use the second hole to drill into the motor and you're done. And I also made a Gridfinity compatible version if you're into that. So let's put it all together. We've got the base and the PCB. One of the magnetic interfaces is also a gear and uses 2 bearings to fit on the shaft. Now let's put the motors in, one from each side, but with both cables facing the same direction. Now the shaft goes in with some spacers, and again it uses 2 bearings to fit in the base. The shaft is terminated on one side with the gear and on the other side with the magnetic interface, and the whole thing holds together with an M4 bolt. I didn't want to mess around with shortening the cables on the motors, so I tried to fit them inside somehow. I used 3 zip ties to guide the cable around, and it seems to fit pretty well. So both cables go around in opposite directions, and then I just tighten it. And with that, it's ready for a spin. With the stepper motors and the drivers, it runs quietly and I have good control of the speed, and with the motors facing in opposite directions, the whole thing is a lot more compact. The interface now uses front-facing magnets and these mechanical detents to hold the disc in place and prevent it from rotating. Quick note here about the drivers, they're quite powerful, so you can decrease the current by setting this trimmer, and the reference pin should have about 0.2 volts on it. To finish it, I'm gluing an LED strip to the back cover, plugging it into the PCB, and then adding covers from both sides. So I'm at a point where I think I have the mechanism somewhat figured out. I've got this test disc here, but I need to figure out what design I want for those discs. So there's a lot of possible designs out there, and I'm going to have to make models, at least a few models out of them, to create different animations, right? So to help me do that, I vibe coded this simulator where I can draw something on this canvas on the left. It gets repeated in a pattern, and then I can animate it and see what sort of animations we get. And I can change the number of instances, right? You can see this wedge on the left here is getting bigger as I decrease the number of instances. So let's try 5. And anything I draw here is going to get repeated and drawn on the right canvas. Right. So let's do some experiments with this. And after playing around with this tool a little bit, I had a few designs that I liked. If you'd like to try this simulator, I will leave a link in the description of this video. And these are the designs I came up with. So okay, I had some fun with the designs, but I had to model them somehow now and fit them onto the printer. To do that, I had a model in CAD with the proper interface in the middle, so I exported that as an SVG, imported that to Inkscape, and basically used it as a canvas to replicate the design. And then I cut it so I had only a quarter left. And by reducing the size into 1/4, I can finally print that. Luckily, I can just import the SVG file directly from Inkscape to Prusa Slicer and print it. So I have the 4 quarters that are connected in the middle by these interfaces, and those have magnets glued inside. And everything should just fit together. So that was the magnetic interface in the middle of the disc, but I also added these small parts around the circumference of the disc to better hold the 4 quarters together. And I'm basically just gluing them in from both sides of the disc. And with the 2 discs complete, it was finally time to see it in action. Okay, that seems to be working pretty well, but the main reason why I made the interfaces magnetic is so that I can quickly change into a different set of discs. So it was back to Inkscape, the Prusa Slicer, and, well, the assembly is pretty much the same. And maybe more discs? Again, Inkscape, assembly, Inkscape, assembly. Well, you get the idea. Okay, I think this might be enough discs now. The microcontroller I used has Wi-Fi, which gives me the opportunity to make a remote controller, which I did. 2 potentiometers for control, a button to change the modes, and a light to see which mode you're in. And that goes into a little box. I could put a battery in there and make it completely wireless, but I thought USB power is good enough. I'm using it in 3 modes. The first one just controls the speed of each disc, so the left knob controls one and the right knob controls the speed of the second disc. Then by hitting the button, I switch into color mode, and one knob controls the color, the other controls the spread of the colors, the gradient. And in the third mode, the speeds of the discs automatically sweep through different speeds, so they slow down and speed up. And here is where the problems begin. It doesn't really handle well any speed changes, but it works well enough that I'm okay with it. And also the video is getting quite long, so I don't think I'm gonna fix it right now. Overall, I'm pretty happy with how it turned out. It has its limitations, especially when changing speeds when using the controller. And at first I thought I would be able to just have it automatically sweep through slow and fast speeds, but it doesn't handle speed changes very well. I think it's because of the play in the mechanism. So the stepper motors have 1:64 reduction, if I'm not mistaken, already inside of them. And then I'm using 3D printed gears to get the rotation from the motor shafts onto this main shaft of the mechanism. So I think that introduces some backlash as well, and the backlash then produces the inconsistencies in speed. I think it might be something else. But other than that, I think it's pretty cool. And who knows, maybe in another 8 years, somebody else will pick up the project and make it better again. Maybe it will be me, maybe not. I have other plans for projects right now. Until then, keep building cool stuff.